This will be the last section in chapter 23. This will be over Huygens principles, section 23.11. So if the position of a wavefront at one instant is known, the position of the front at a later time can be constructed using Huygens principle. Every point of a wavefront may be considered the source of secondary wavelets that spread out in all directions, and the new wavefront is the surface that is the tangent to the wavelets. So you can see here you've got them coming through. Let's say you've got a wavefront at this particular point, and then you're looking at taking points along the wavefront here, representing them as waves. As we look at something propagating out from that primary wavefront, we're looking at the secondary wavefront here, and all of these little bows here are going to be as if we started a wave from this particular point and the circle had just propagated out. We do that for each one of these, and that's the wavefront as we see it. So again, every point of a wavefront may be considered the source of a secondary wavelet that spreads out in all directions. The new wavefront at a later time is then found by constructing a surface tangent to the secondary wavelets, which is then the envelope. So we're looking at this part of that secondary wave as being the sum of the wavelets here that is sort of a tangent to what we're seeing here from the original wavefront. So mirages are often interesting, demonstrating Huygens principles in action. So when you got a surface or pavement or desert sand that is heated intensely by the sun, a hot, less dense layer of air with smaller end forms near the surface. Speed of light is slightly greater in this hotter air near the ground. And Huygens wavelets have a slightly larger radii because they move faster and travel farther in a given time interval. As a result, the wavefronts tilt somewhat, and rays that were headed slightly towards the ground can bend upwards. As shown in this particular figure, light further from the ground is bent less, but travels in a straight line. So as we're seeing this here, the hot air near the ground is a smaller N than the cooler air higher up, so light travels faster near the ground. Thus, Huygens wavelets near the ground have a larger radii, and the wavefronts tilt as they travel. So the observer sees the object in its natural position with an inverted image below it, as though seen in the horizontal reflecting surface. Even when the turbulence of the heated air prevents a clear inverted image from being formed, in the mind of a thirsty traveler can interpret the apparent reflecting as surface as a sheet of water. In other words, you're seeing this reflected image here that's being interpreted by your brain as perhaps maybe they're standing in water or something like that. Not that that's going to help you a lot in the desert. So anyway, that's chapter 23. Hope you got something out of it.